So this is the rest of 4.7, which is inverse functions. And then the next thing we'll do is 5.3, but I'm not doing it because I don't know, because I don't want to get you messed up for Friday when I'm not going to be here. Okay? So we'll start doing that on Monday. So let's just do a quick review and see what you know. All right? Inverse sine.
Yes.
Inverse sine. Tell me what his domain is.
-1, +1.
Inclusive or inclusive. Okay? So -1 to +1. Good. What about range?
Negative infinity, positive infinity.
Nope. It's
It's negative pi over 2 to pi over
Yeah.
2.
Inclusive or exclusive? Inclusive. Okay? So negative pi over 2 to positive pi over 2. All right? And he's restricted to what? What quadrants?
1 and 2.
Quadrants 1 and 4. He is positive where?
1.
In 1. And he's negative in 4. Okay? So what if I have a negative value? All right? Then I find where's the angle that gives me that value, right? And then what do I do with it? Slap a negative on it. Okay? And that's all you have to do. Very good. All right, so let's do inverse cosine. All right, what's his domain?
-1.
-1 to 1, inclusive. What's his range?
0, 0.
Yeah, 0 to pi. 0 to pi. Because, look, are these two things kind of saying the same thing?
Yeah.
This range and what quadrant I'm in? All right, see, 0 to pi over 2, that's quadrant 1, and 0 to negative pi over 2, that goes down to the bottom, that's quadrant 4. So 0 to pi would be quadrants what? 1 and 2. Which one's the scary one?
2.
2. Okay? Because this one is positive and this one's negative. Why is this one scary? Can I
Because you
just
can't
slap a
slap it.
negative?
No.
No. You have to place it in the second quadrant. So what that means is that you have to go to, over here to this 1 pi. So if you're talking about pi over 4, all right, you have to go over here to 4 pi over 4 and back it off 1, and where are you?
3 pi over.
Very good. Or if you're at pi over 3, which is up here, 3 pi over 3 and back it off 1.
2 pi over 3.
And pi over 6 would be 6 pi over 6.
5 pi over 6.
5 pi over 6. And y'all, those are my only choices, right? You agree?
Yes, ma'am.
I mean, we're not doing any other because they're not special. All right? So, inverse tangent. Inverse tangent. We didn't do an inverse tangent yesterday, so we're going to do one today. What was my domain? Yes, negative infinity to positive infinity. Good job. What about, what's my range?
-pi over 2, pi over 2.
Exclusive, because those are my asymptotes. Those are those undefined points, okay? So, negative pi over 2 to positive pi over 2. And they are exclusive. Did I hear something? I thought I heard a robot voice. No?
No, you just heard someone go,
Okay, sorry. Okay. No, it sounded like Siri or something was talking. Saying, I'm sorry, I can't help you with that right now. That's what she always says to me. All right, so what quadrants are they restricted to?
1 and 4.
1 and 4. Obviously, he's positive in 1 and negative in 4. So is this one a difficult one? Is he like cosine?
No.
He's like what?
Slap a
Sine.
negative.
Slap a negative on it. Okay, so let's do a couple of inverse tangents, okay? And then we'll learn what we're going to learn today, and then we'll practice a few problems, and then I'll give you some problems to practice, okay? So this is example 4. It's not really in your book. I made it up, okay? So the first one we're going to do is arctan of 0. Arctan of 0. Do you want me just to let you give it a try, or do you want me to help you first?
We'll try.
Okay.
I'm not allowed to pull out my unit circle, correct?
Well, remember this, if you never even attempt to write that first quadrant down, okay, you will never ever memorize it, okay? You have to your brain has to go, oh man, I really gotta get that thing learned. Okay, so if you're struggling, a couple of hints is that tangent is what? How do I express tangent in terms
Y
of
over X.
X's, Y's, and R's? Very good. He's Y over X. So I'm looking for something. Do I care if it's a fraction?
No.
No, I'm only, what part of the fraction would I be looking for on the points?
Top.
Just the top, because the bottoms are the same on all the points, guys. All right? So I would just be looking for the top. But I'm looking for something that has Y as a 0. I don't really care what X is. Obviously, he's not going to be 0 because that'd be the origin, and he's not on our chart.
I figured it.
Okay, you got it?
No.
Here's my unit circle right here.
Oh, wait.
Okay? Do you see something that has Y as a 0?
Yes.
No, 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 no.
Yes.
Whoa. So what's my answer?
1.
What?
Undefined.
I don't know. 0.
People,
Nothing.
what is the angle right here?
Nothing.
Nothing. What's the number for nothing? Because if you write the word, I'm going
0
to
with
the
a line
wall.
through it.
0.
0.
0. Good.
Oh,
Nine.
you're finding the angle.
Yes.
Okay.
0.
Good job.
0 what? Radians. Why? Because by definition, inverse functions are always done in radians. Okay? This morning, one of the kids said, can we do this in degrees? And someone goes, no. And I said, no. They're always done. Now, are they going to later on change that up? Are they going to later on say, hey, I want you to work with degrees now? All right? They're going to do that to you. But right now, all you had to do was, this is asking, what's the angle that has a Y at 0?
So just for 10, are you, do you look at the Y's for whatever number it is?
Well, you can't just look at the Y, it's Y over X. We're gonna do another one, and maybe, I think you'll see it, okay? All right, so let's do this one. Same thing, just a different way of writing it. Inverse tangent, arctangent, tan to the minus 1, those are all the same thing. The angle whose tangent is this number, okay? Now look, it's still Y over X, guys, okay? If you want it to be 1, what do Y and X have to be?
Same.
The same thing.
But different
So, well, I'm not even looking at the negative right now. We're not even gonna worry about it, because we know all we have to do is slap a negative on it.
So the number that's in the parentheses, like, are you looking for like where Y is -1 or X is -1?
I'm not thinking about the sign. I'm looking for where Y and X. Now look, look,
Oh, where Y over X equals
equals 1. 1. I'm just doing 1, guys. We're not addressing the sign, because this is an inverse tangent. What did you just tell me about this negative? Slap a negative on it. People, just find your 1. That's all you're doing. So if I want Y over X to be 1, what do you know about Y and X? They have to be the same thing, people. Okay? Look, this would be 0 over 1. That's 0. This would be 1 over the square root of 3. Is that 1?
No.
This would be 1 over 1.
Yeah. Oh my God.
What if you had written it in the rationalized form?
Square
It
root
would
of
be
2 over square root of 2.
That's exactly right. The square root of 2 over the square root of 2, which is
1.
1. Okay, this other one, the square root of 3 over 1. Do you understand that your questions were not even relevant, were they? Look, on tangent, you can't look and find this number. You have to make it. Do you understand what I'm saying? Sine and cosine, I can look, because sine's Y and cosine's X. I can look and find them and then write the answer down. But tangent, you have to make him. He's Y over X. He's not just a Y or just an X. Okay? So, obviously, it's pi over 4. It's negative, so what do I do to it? Slap a negative on it. Negative pi over 4. All right, so everybody okay? Yes?
What is 3 pi or 4 words too?
No, because it's not within my range. You see what I'm saying? That's why I said don't look where it's a negative. Alright? So, I said don't look where I was negative. I shouldn't have looked out there. I looked out there, but I heard noise, so I immediately glared out there. Sorry, mistake. Okay, so anyway, alright, so you ready to learn something new?
No.
Okay, so you're gonna like this. You're gonna like this. Alright, so if, you know it's bad if I'm writing in cursive, okay? If x is greater than or equal to -1 and less than or equal to 1.
Wait, why are you writing so small?
Don't write a lot.
I don't know.
She's writing them.
I was
What
going
is
to-
that? Cursive is like a new language, Davis. I feel like
If x is greater than or equal to -1 and less than or equal to a +1. Okay, have we been saying this in a different way?
One way.
Yeah, people, we've been saying this, talking about it, that's my domain. You said it was from -1 to 1. Okay, so obviously, which two might I be talking about?
Sine.
Sine or cosine, okay? And y,
Wait, is domain what X?
yes,
Okay.
and y is greater than or equal to -pi/2 and less than or equal to pi/2. Now you know
Sine.
who I'm talking about. Sine, right?
Yeah.
Because cosine's 0 to pi. So we've been saying this like this. The range is -pi/2 to +pi/2. Okay? We've been saying it, but we've just been using interval notation, and all of a sudden they popped up and said, hey, what about some set notation? All right? Then, this is an if-then statement. Then what? Oh, watch this. The sine of the arc sine of x is equal to x. And the arc sine of the sine of x is equal to x. Oh, pardon me, this is not x, this is y. Sorry. I gotta calm down. I was listening to y'all's comments and not paying attention.
To be crying on the inside.
Okay, so y is equal to y. Alright? Now let's do the next one. If x is greater than or equal to -1, less than or equal to 1, and y is greater than or equal to 0,
What?
and less than or equal to pi, who am I talking about?
Cosine.
Cosine. You should be able to write the rest of the statement, people.
I know, but you just break it down to us.
It's gonna say the cosine of the arc cosine of x is equal to x, and the arc cosine of the cosine of y is equal to y.
You're gonna have to sit there just for a second because that was a lot to take in.
Yeah, I'm just playing.
Hey, that ain't funny. You're gonna explain it.
Wait, so do you want to
Zero.
explain this to us, like how?
I'm
this-
gonna write them all down and then I'm gonna come back and point some things out for you. And then some of you will get it when I point things out to you, but most of you will get it when we start working some problems. The first one, some of you will get, a few more will get it then, but the second one will most definitely pull a lot more people in. Some people, you may never get.
Were you ever? a
That's
hippie?
what I was laughing at, Davis, because I was.
Just Davis, were you ever a hippie?
I could see that.
Yes.
Like I was like 1 year old in the hippie age, so I doubt I would be.
You were born.
No, yeah,
Yeah.
that was in the 60s. I was born in the 60s. I'm
My great
18,
grandma was born in the 20s.
okay?
Good Lord.
Could be considered an NT.
So I.
My great
No, she
great
don't.
great
Okay.
great great.
Obviously you finished. So if,
Oh, that's an if, is what you're doing.
okay, if, that's the word if. I and F, that usually spells if, okay? If x is an element of the real numbers.
Wait,
Why is X an element?
Whoa.
Okay, stop. This is, remember what I told you, this is set. They're using set, okay? So they're going back between set notation and interval notation.
Is that an E and a R?
Okay? Yeah, this is not an E, it's kind of an E, but it means it's an element of, it's a C with a little line in it. Okay, that's actually how you write it. It's a C with a little line in the middle. And your real numbers, how do I know that that R stands for the real numbers?
Cause it's capital.
He's double barred. A double barred R is the real numbers. A capital R is just a capital R for Richard,
Carbonyl.
Rochelle, or whatever, okay? All right, so what have we said? What was my domain? Obviously, I'm talking about tangent people.
Oh, negative infinity,
There
positive
you
infinity.
go. Negative infinity to positive infinity.
Oh, so
That's an
all real
element of
numbers?
R. Yeah, all real numbers,
Oh, yeah, I see that.
okay? And
Oh my god.
Oh, hey, my
Um,
asymptote.
Y
Is there an
is
asymptote?
greater than negative pi over 2 and less than positive pi over 2, okay? So notice I didn't put or equal to because those are my asymptotes, all right? Not greater than or equal to, but just greater than, between them, confined by them, set those boundaries. Then, the tangent of the arc tangent of x is equal to x, and the arc tangent of the tangent of y is equal to y.
You're giving me
Yes.
the Tanny.
Okay, so let me point some things out to you and try to make a few connections for you, okay? So first of all, these x's, they're numbers. Do you understand that? From -1 to +1, that's just a number, guys, okay? So, look, the angle whose sine is this number, then when I take the sine of that angle, what will I get? That number. Okay? This right here is the angle whose sine is this number. So when I take the sine of this angle, I better get that number. Alright? So notice this. The angle whose sine is a number. The x's are numbers. Okay? The y's are angles. You take the function of the angle, the sine of the angle. You can't take an inverse sine of an angle. You're looking for the angle. Do you understand what I'm saying? Okay? So if you do an inverse function, you better have a number. If you're doing a function, you better be an angle. Those are my y's. Okay? The very first thing you always want to do is make sure that you're fitting it within your restrictions. Alright? If I'm doing inverse sine, I'm restricted to between -1 and 1. Okay? If I'm doing the inverse sine of a sine, then this angle is restricted to between -pi/2 and +pi/2. Okay? You have to make sure they fit within your restrictions. Alright? Now they're going to do some, there's a couple in here that are a little bit, I don't know, I don't like them. I started to say, never mind, I'm not going to say what I started to say. So, I would if we want to pull it, but anyway. So,
Whoa, Miss Davis.
well, I was just gonna use a word, but then I thought I had used that word earlier this year, and y'all, I didn't mean it like that.
Wait, is it the word you said yesterday to not to use because you're recording?
No, it was the, never mind.
Can I say it?
Right. Yeah, the one with the tattoo. Yeah, that's the word I'm talking about. All right, no, not that one. So here we go. So let's try some problems. Example 5. Find the exact value. What does that word exact mean?
No calculator.
Yeah, no calculator. As soon as you see the word exact, you know that that's just a clue for you. I don't need to be using a calculator. Now, if you had a calculator, could I use my calculator to check my answer?
Yes.
Oh, most definitely, especially on the SAT test and stuff like that. But y'all listen to me. Do you have lots of time on the SAT?
Yes.
You don't. Okay? You don't have a lot of time. Okay? No, that was Eli said
I
that.
was stuck in there for hours.
So, then it says, if possible.
He got an hour nap during that.
Okay, so find the exact value if possible. All right, so here we go. Here's the first one. We're going to find the tangent of the arc tangent of -5. Okay, so listen to me. What did I tell you the very first thing? Okay, and check and see if it fits within your constraints, okay? So these are my two constraints for tangent. All right, so am I talking, this -5, you notice it didn't tell you if it was an X or a Y, you gotta figure that out, okay? He's an X, it's an inverse tangent, inverse functions go with the domain. So is this -5 within my domain?
Yes.
Okay, so watch, I'm gonna do something. This is an angle, we're gonna call it theta, okay? So tell me the angle whose tangent is -5. Theta, right?
Oh, yeah.
So what is the tangent of theta?
-5.
There you go. Mhm,
Is it that simple for all of them?
mhm, no.
Okay, all right.
Is the
Yeah.
test gonna be exactly like this?
Okay, so let me do one. Okay, remember how I just told y'all that I thought the second one would drag more people in to the understanding circle? Alright, so let's do this one. And I think this one because you know this one. This one's familiar to you. Okay? So the sine of the arc sine of 1/2. The sine of the arc sine of 1/2. Okay, so first of all, is 1/2 within my constraints?
Yes.
Okay, so obviously I'm looking at these constraints right here between -1 and +1. So yes, he is. So now I can work the problem. All right, so cover this part up and do this part right here. Tell me the angle whose sine is 1/2. You're thinking about your unit circle. I want the y to be 1/2. What is it?
pi/6.
Pi/6. Okay, so now you're going to find the sine of pi/6. See, this right here.
Oh.
Yeah, see what I'm saying?
Oh, that's.
So this is pi/6. This whole entire thing right here is pi/6.
Now with the
You
sine
said
of
the angle whose sine is 1/2 is pi/6. Everybody understands that, right? Now tell me the sine of pi/6.
So
1/2.
so you're basically doing PEMDAS. You're doing what's inside the parentheses. You solve that, you get pi/6, and then what's the sine of pi/6, and then it's 1/2.
That's exactly
Is it
right.
always the number that's in that little bit of moment?
That's what I'm wondering.
Well, if these two things are the inverses of each other, if these two things are the inverses, then it is. And also, if it's within your constraints. I'll show you how to do it. I'm gonna show you how to do it. I like those, they're my most favorite ones, okay? Because I think they're easy, they go back and review a little bit, but they're not hard. Okay, so here we go. Are you ready? Now, I told you that there were gonna be some snarky problems, right? This is one of them, all right? Get ready. No, not sharky, snarky. The arc sine of the sine of 5 pi/3. Okay? I want you to see what you can do about this. I pretty much know what your answer's gonna be.
Nothing.
It should be something, people. You should know to do something.
Wait.
What's the first thing I told you to do?
It's not in the constraint.
Check your
It's
constraints.
not in the constraint.
Okay. So Madeline says this guy's not within my constraints. Who am I looking at? X's or Y's?
Wow.
Okay, so we're going over here to a Y.
Oh.
Is 5 pi/3 between -pi/2 and +pi/2?
No.
Okay, so normally, that's why I said this problem's kind of snarky. Normally, I would say this is not possible, okay? But watch what happens.
Wait, it's
Okay.
a negative.
There you go.
Yeah, I knew it.
Can you represent this another way?
Yes.
So 5 pi/3 is in what
Third
quadrant?
quadrant.
What?
Oh wait.
Second.
Fourth quadrant. Fourth quadrant. What do you mean second quadrant? People, 2 pi/3 is in the second quadrant. What's in the third quadrant?
3, 4. Thank you, Amy.
Go look.
Thank you.
Okay, shh, stop. This is 1 pi. This is 3 pi/3. Okay, so what's in this quadrant?
2 pi/3.
2 pi/3. What's in this quadrant? 4 pi/3. 5 pi/3 is here. Okay, so 5 pi/3 is right here.
Oh.
How far away is he from 2 pi?
5 or 3.
So could I call this negative pi over 3. Is he like a reference angle except that he's negative? Do you see what I'm saying? Are you with me? So could I write it like this? The arc sine of the sine of negative pi over 3. Is that the same thing?
Yes.
Yes, it is. Okay? So now, is he within my constraints?
Yes.
Is pi over 3 within your constraint between negative 1/2 and positive 1/2?
Yes.
Yes, negative 1/3, yes. So what's my answer? Negative pi over 3. Negative pi over 3.
Miss
Wait,
Davis,
Yes?
I just wanna point you out,
Mm-hmm.
you gave me this sticky note that says, show me your knowledge, and then I knew it was negative. I wouldn't have done that without the sticky note. So
I'm
okay,
so
thank you.
glad my sticky notes are helping y'all. Y'all don't throw my sticky notes away, because I still got 2 classes that have tests, okay? So, and I'm kinda trying to encourage
Can
my,
you do that for me?
I can do
Me
that.
too, I really like
You
this.
have one right there, but I'm gonna do some more later.
What's your second?
okay, so,
You can do this.
it,
Hush. Eli, go.
actually, I completely have no clue how to say what I was gonna say, so it's okay.
You wanna give it a shot, and we'll try and figure it out?
Okay, it's 5 pi over 3, right? And you said we have to go negative pi over 3, which
Mhm.
means that 2 pi is 360. Okay, this is so hard to explain.
No,
My brain's picking it up right now. If I figure out how to say it.
Okay, if you figure out how to say it. Alright, so let's do another one. Are you ready? So this is D. Okay? This is D. Now, listen to me. I'm going to warn you about D. D's not snarky, but he's very tricky. Alright? So let's see if you're tricked.
What's the difference between snarky and tricky?
Snarky is, I don't really like the way they did that. That was like, to me, that was kind of mean.
Right.
Alright? This one's not mean. It's just a little tricky. Okay?
She dyed her blonde.
Shh. Let's go.
Oh no.
What looks snarky to me?
This one looks quite hard.
No, Sean. Because I know what he was thinking. I know what he was thinking, that's why I'm saying no.
Wait, isn't
No,
that?
Sean. Huh?
It's okay, man.
I think I know, but I could be totally off.
I have no clue what.
Okay, so let me tell you the tricky part of this problem, okay? This pi right here,
Yeah, it's not in the range.
okay, but is this a range?
Yes.
No.
No, it's an X.
That's exactly right. An inverse function is a domain. So this pi actually represents what?
X.
Yeah, 180.
No, he's not a range.
Domain.
He's a domain.
Oh,
He's a number. He's a number. What is pi?
180.
3.14.
That's as an angle.
3.14.
3.14.
It doesn't
So
fit.
that's exactly right, y'all. You can't work him. He is outside my domain, okay? He is not possible, okay? Why? Because pi is equal to 3.14. So how do they try to trick you? They put a pi where normally we think about pi's as being angles, right?
180.
Okay? And this pi is not an angle. How did I know this pi was not an angle? Because you can't tell me the angle whose cosine is an angle. You see what I'm saying? That doesn't make any sense. Okay? He's outside my domain. Bailey.
Okay, so the smaller parentheses is always gonna be an X.
No, not necessarily. It depends on what they're doing. Look, this is what I was trying to tell y'all. Okay, do you see over here where every time it's an X, it's an inverse function? It's either tan to the minus, this is the same thing as
So
tan to
if
the
like
minus 1.
tan was inside, then it's
Then that's a
Y.
Y. See over here? See the functions?
So you just have to know like.
So you gotta look inside here. That's an inverse function. That's an X.
Okay.
Okay? Alright, Sean,
So if domain is out of range, it can be not possible.
outside of domain.
Yeah.
Okay.
Whoa,
My
whoa.
head hurts
Wait.
so
If your
bad.
number is outside your domain, it's not possible.
But for range, you can always solve it.
No, range you can't, unless you can make it work like this. You have a little more play with the range, so you have to be careful, okay? But if this had been 4 pi over 3, we couldn't, no. Okay?
You're right.
If it's not a special angle.
If it's not a special angle, we're not doing it,
She's not gonna do
okay? All right, so let's do a different one. Are you ready? I'm gonna do 3 more, and then I'm gonna give you some problems.
Oh,
So-
God.
What time's the bell ring?
Good God.
Okay,
That was-
so here's the first one.
Oh, wait.
The sine
Do you again?
of the arctan
I don't like that.
of 4/3. Okay, so what's different about this one?
They're not the same.
That's exactly right, they're not the same. These are my favorite ones, okay? Because I do have to make sure that this guy's within my, what? Domain. Inverse functions do domains. Functions do ranges. Is 4/3 within his domain?
No, yes.
Yes, he goes from negative infinity to positive infinity, people, okay? So he's covering everything. All right, so I know he's okay. So let's draw a picture of him, okay?
I'm down.
Now, I want the angle whose tangent is 4/3. Inverse tangent is restricted to what 2 quadrants?
1 and 4.
This one's positive, so where does he have to be?
One.
Okay, so I'm gonna draw him up there.
Let's go.
Okay, now remember this, this is the angle, that's my angle theta,
Yes.
okay? Once I find out what that angle is, I'll take the sine of that angle, okay? So this is theta right here. And I know that his tangent, what is the definition of tangent in terms of sides of a triangle?
Over it.
Sides of a triangle.
Opposite over it.
Okay, opposite over adjacent. You could say y over x and know that this is y and this is x, if your brain allows you to do that. Some people's brain will be like, no, stop.
Yeah.
Okay, so 4 is this side and 3 is this side. What's this side have to be?
5.
5, that's a Pythagorean triple. If you didn't remember that, you could always go 3 squared plus 4 squared
So the
equals
answer
c
is
squared.
5.
And so 9 plus 16 is c squared.
25 squared.
C squared is 25 and the square root is 5.
Is that the
Okay?
same thing with 7, 24, and 25?
It really
Yes.
wouldn't matter where you put those.
Okay,
numbers on.
so here we go. Shh. I want the sine of theta. There's theta. Tell me what his sine is.
Y. 4.
Stop.
Wait.
Sine is, what's the definition of sine in terms of sides?
Y over R.
Opposite over
Okay.
hypotenuse. Okay, opposite
Okay,
over
go ahead.
hypotenuse. So 4/5. Don't make this hard, because y'all, this is not.
That was hard.
You
That
just
was-
combined like 20 things
You just
in
put a
math into
triangle
one.
in
I did combine a lot of stuff, but is it stuff we've already covered?
Yes.
Yeah.
I'm gonna pay you 3 years.
My head is like spinning at the moment, like.
Okay, so here we go. Shh, here we go. E, the next one. Secant of the arc tangent of negative 3/5. Now, obviously, people, what are you going to need to do?
Look.
Draw a triangle.
Draw a little triangle, baby.
Yeah.
But in quadrant.
Oh, in quadrant what?
4.
Very good.
How'd
Put your
you know
negative
this?
where it belongs. Okay, in quadrant 4, who is negative?
X.
Y.
No.
X.
X. No.
Y.
No. Y is negative. Quadrant 4, right here.
Oh,
X is
quadrant
a
4. Sorry, I wrote it in quadrant 2. Hey, you said
No,
X
but
too.
it's the arc inverse
No,
tangent.
you said X.
Inverse
you said X.
tangent,
You
I
said X.
said no X. That's what I said.
Come on. We have it on video.
We got
Davis.
this.
I said
55.
Can we get a playback real quick?
We got 3 minutes, Miss Davis.
Okay, we gotta hurry.
No, we don't.
Yes, we do.
Okay, so tangent is opposite over adjacent. So opposite, here's my theta, okay? Opposite is 3 and adjacent is 5. Now since no, the x's are not negative, okay? This guy has to be negative.
How do you know your favorite?
It's always always here. Your theta is always there.
Why is that
You'll never be over there. That's my angle,
It's
okay?
always close
It's always
to the
gonna be by the
origin.
origin,
It's 7.
okay? No, it is
I
not.
didn't do math. I was-
So 5 squared plus negative 3 squared, what's 5 squared?
25.
3 squared.
9.
So C squared is equal to 34, so C is the square root of 34, which cannot,
Can you reduce?
Nope, they cannot be reduced.
We have a legitimate 2 minutes.
No, we don't.
okay, so now we're gonna find secant. Now look, here's what my brain does. My brain says cosine is adjacent over hypotenuse, so what must secant be? Yeah, hypotenuse over adjacent. So what is my hypotenuse?
30 or 34.
And what is adjacent to my angle?
5.
And that makes sense. Secant in the 4th quadrant, just like cosine, is positive. And all things
Oh,
positive.
this hurts my head.
Okay, here we go to the next one. Are you ready? Questions?
Do we have time?
We're in second.
Yeah, that's why I'm writing it fast. And y'all are saying, no, stop.
Go bananas. My cat, they got ran over at 4th grade. That was his name. Go bananas.
Somebody said run over it.
Yeah.
The sign of the arc cosine of negative 2/3. Where's he gonna be, guys? Second quadrant.
Yes.
Cosine is adjacent over hypotenuse. So this is negative 2, and this is 3. If you figured this guy out, he's the square root of 5. Negative 2 squared plus y squared is equal to 3 squared.
Wait, what is sign opposite over adjacent?
Okay, sine is opposite over what? Hypotenuse. So here's my angle, always by the origin, guys. Opposite over hypotenuse.
That's crazy, guys. We just did that in a minute.
Because we're so smart. All right, so anybody got a question?
No.
All right, so test tomorrow, guys, test tomorrow.
Sean, I was asking you how. Sean, you get broken?